Friends, in continuation, let's see what is beta decay, right? Yesterday we learned about alpha decay. Let's see what is meant by beta decay, right? है ना? So, beta decay is a process in which either neutron is converted into proton or a proton is converted into a neutron. Yes or no? Just right. Beta decay is a process in which either a neutron is converted into a proton, either a neutron is converted into a proton or a proton is converted into a neutron, or a proton is converted into a neutron. That means, student, the n by z ratio is altered in beta decay. What is meant by n by z ratio, right? N by z ratio, right, is यहाँ पर हम ये भी कर सकते हैं, the ratio n by z is altered because number of neutrons and protons changing, na? Is altered, right? So what is this n by z ratio? N by z ratio means neutron proton ratio. This is what n by ratio, or we can also say that nuclear ratio. Sometimes you will be getting this one as nuclear ratio, and that is also known as neutron proton ratio. Neutron proton ratio, correct? Yes or no? So that means, students, neutron proton ratio means atomic nucleus is the ratio of its number of neutrons, right, to its number of protons. How many nuclear neutrons and how many protons? Among stable nuclei, मतलब stable nuclei means naturally occurring nuclei. This ratio generally increases with increasing atomic number. Yes or no? So normal. See here, this is neutron proton ratio. ठीक नहीं? So actually क्या होता है? Let एक nucleus बन गया. If a nucleus is formed with more number of neutrons, so then मतलब जितना न्यूट्रॉन चाहिए उसको उससे ज्यादा हो गया. Formed with the more number of neutrons than needed for stability. So in the extra nucleus, what will happen? A neutron will be converted itself into a proton to move towards stability. Similarly, if a nucleus is formed with more number of protons, how many number of protons are required for stability? अगर ज्यादा proton form हो गए तो क्या करना पड़ेगा? A proton will convert itself into a neutron. Such a transformation takes place because of weak forces operating within a neutron or a proton, right? That means when a neutron is converted into a proton, an electron and a new particle is named anti-neutron are created in the emitted form of the nucleus. That means, see here. So let's see here. So there are three modes of decays, right? जैसे कि the change in atomic number is due to the मतलब एक इलेक्ट्रॉन emit भी हो सकता है और एक प्रोटॉन भी एमिट हो सकता है और एक पॉजिट्रॉन भी मतलब कैप्चर हो सकता है. तो इसीलिए डिपेंडिंग अपॉन द मोड्स ऑफ डीकेस, बीटा डीकेस आर नोन एज, बीटा डीकेस को भी क्लासिफाई किया गया है. क्या है? जैसे कि बीटा माइनस डीके, there is electron emission, there is electron emission, right? Then beta plus decay, beta plus decay means, right, positron emission, there is positron emission. Then electron capture, that is K capture. Electron capture, one by one we'll discuss what happens in every case. Electron capture or K capture, right? है ना? Students, first let's discuss about beta minus decay. There is electron emission. So what happens? Next, give heading beta minus decay, or that is also known as electron emission. Correct. So let's there is a element XZA. So here reactant products plus A, right? Plus to balance it what? Electron plus Q will, right? और ये जो हमने लिखे electron -1 0, that means that can also be written as beta -1 0, right? है ना? 1 minute. Students, see here. So one thing is that this is the beta decay electron emission, yes or no? So by we can see by also momentum and energy conversion will get total energy, right? Mass of Y means that one, mass of electron plus mass of Y into total energy Q, right? This mass is mass of electron, so electron plus mass of Y into Q. Yes or no? Students, mass of electron is less than that of mass of Y element that we have taken. We consider that all energy is taken by the electron. So from the above result, we'll find that all the beta particles emitted will have the same energy, and hence they have same radius. Okay. So here, in fact, actually what happens, this is the total energy we calculated. This is the beta decay electron emission, right? And as I told, uh, students, when neutron is converted into proton, just remember neutron is converted into proton, right? Neutron is converted into proton, right? And or an electron, the particles, there is another, and a new particle is named, that is anti-neutron. That is anti-neutron, neutrino are created and emitted from the nucleus. And emitted from the nucleus, right? So that neutron is equal to P plus electron plus. So this, so ये जो symbol है new bar, right? See here. This is new bar, correct? So that is anti-neutron. This is denoted by the symbol. This symbol is anti-neutrino, right? Anti-neutrino. Right? So it is supposed to have zero mass like photon. It has zero mass like photon, correct? And it is also chargeless and has spin quantum number. I'll say about what is spin quantum number later. And has spin quantum number half. 1 minute. Just note it. So, and has a spin quantum number plus minus substance. What is meant by spin quantum number? So spin quantum number means it describes, right? It describes the angular momentum of an electron. It describes the angular momentum of an electron. And student, actually what happens, an electron spins around the axis and has both angular momentum and orbital angular momentum, because angular momentum is a vector. So spin quantum number has both magnitude. So that's why we're saying total quantum number half, that is in the direction clockwise or anti-clockwise, that is plus or minus. That's why we wrote spin quantum number is half, right? Understood. Next, see here, the electron emitted from the nucleus is called beta particle. So in this case, in the equation that we saw here, right, the electron, right, the electron emitted from the nucleus is called beta particle and is denoted by the symbol beta minus, right? The electron emitted from the nucleus is called a beta particle, and is denoted by symbol beta minus, right? And student, a stream of such beta particles come from a bulk of unstable nuclei is called beta ray. Yes or no? A stream of such beta particles, right, coming from a bulk of unstable nuclei is called beta ray. बहुत सारे बीम जब आएंगे तो उसको क्या कहते हैं? Is called beta ray. And the beta decay process may be represented. So in that case, the beta decay may be represented X, as you wrote, ZA, right? Y, Z plus A atomic number plus electron plus V. In the same way, also electron can be written as beta, ZA, Y, Z plus 1, A, correct? Plus beta minus, that is same. Then anti-neutrino, right? So it is also called beta minus decay. Yes or no? That is also known as beta minus decay. Okay? That's why the name beta minus decay. Understood? No? Because as negatively charged beta particles are emitted. Yes or no? And the rest mass of the initial constitution is, right? The rest mass. Nikalte hai. Let's find the rest mass. The rest mass of mass energy. The rest mass energy. Mass energy E is equal to mc square. We have to calculate the mass energy of the initial constituent is ui is equal to how much? Mass x za, right, minus z me into c square, and then the final constituent, right? The final constituents is, right, uf is equal to m y z plus 1 into a minus z plus 1 into me plus me. There is the final reactant c square. And when atomic masses are used, uh, it may be noted that the rest mass energy of the electron created is not subtracted in this equation. Because of this last mass, the residual nucleus does not share appreciable kinetic energy. So from there only you can also calculate the Q value. So in beta decay process, finally the nucleus is is converted into a proton with emission of electron and an anti-neutrino, right? So that we saw mass of atom Z, mass of atom Y, then M is mass of electron. From there only you can calculate. Okay. So student, let's see one example on this beta negative decay process. Let's take an example. Student, let एक example लेते हैं. From 198, that is mercury 198 plus beta minus plus antineutrino. Okay. So ये जो mercury 198 represents the mercury nucleus in an excited state. Yes or no? ये जो स्टार लिखा गया है इस मर्क्यूरी 198 का मतलब क्या है? It represents, right? It represents a mercury nucleus. It represents the mercury nucleus in an excited state. In an excited state at energy 1.088 MeV, right, above the ground state. And what can be the maximum kinetic energy of the, उसने क्वेश्चन में पूछा है, right? In the question it is asked, see the question here, it is asked what can be the maximum kinetic energy, what can be the maximum kinetic energy of the electron emitted for atomic mass of atom 198 is 197.968233 atomic mass unit, and mercury 198 का क्या है, that is also given 197.966760 atomic mass unit, right? तो यहाँ पर हमें मैक्सिमम पॉसिबल काइनेटिक एनर्जी ऑफ इलेक्ट्रॉन एमिटेड, मतलब टोटल एनर्जी कितना, क्यू वैल्यू निकालना पड़ेगा पहले. सो लेट्स गो फॉर दिस क्वेश्चन, राइट है ना. सी हियर स्टूडेंट्स, so what is the q value? Always q value is equal to, how to calculate, mass of atom 198, yes or no, minus mass of mercury 198 whole into c square. और अगर एनर्जी देखेंगे स्टूडेंट्स, जब हमने ये देखे कि मर्क्यूरी 198 जो है उसका कितना एनर्जी है, 1.088 MeV, which is more than the ground state energy, है ना. एंड द काइनेटिक एनर्जी एक्चुअली अवेलेबल कैसे निकालेंगे, तो सब्सट्रैक्ट कर देंगे उतना. सो क्यू वैल्यू से जो एनर्जी आया था, दैट इज मास ऑफ आयरन 198 माइनस मास ऑफ मर्क्यूरी 198 सी स्क्वायर, राइट, होल माइनस 1.088 MeV सब्सट्रैक्ट कर देंगे. तो पूरा जब इसको सब्सट्रैक्ट करेंगे, ये मास कितना आया स्टूडेंट्स, 197 आया था, 968233 U माइनस 197.966760, राइट, इतना आया है. और उसमें क्या डिवाइड कर देंगे, 931 डिवाइड कर देंगे ताकि MeV हो जाएगा, और माइनस 088. अगर पूरा सब्ट्रैक्ट कर देंगे स्टूडेंट्स, तो ये आ जाएगा 1.3686 MeV अप्रोक्सीमेट, minus 1.088 MeV. So totally you got how much, 0.2806 MeV, right? This is called the maximum possible kinetic energy of the electron emitted. This is maximum possible kinetic energy. This is the maximum possible kinetic energy of the electron emitted. Right here. Just keep in mind these things. Next class we'll see about beta plus decay, and that is beta not decay, that is KSL electron capture.